Righto, so here's this Amiga 500 power supply fixed, I believe. I hope so. There was a rather obvious fault. Here's the bin of parts I took out from it. Clue number one, blown blackened fuse that really exploded inside. So that was a catastrophic failure of the fuse, which tells me, so one job tells me that something completely went short on the main side of the supply. If it was something on the secondary side, it would not explode the fuse like this. So this is some decisive short on the main side, and that's good. That's really nice. We know there are not too many components on here that could do that. Nothing was visibly deformed or blackened or exploded, so I just pulled out the old multimeter and started measuring the obvious culprits, the diodes. Very often a diode will go, and yeah, that's what happens here. So the diode here, one of the rectifying diodes of the mains, 1 in 4007, a typical 1000-volt diode, had gone completely short. So yeah, the other ones were half a volt across. This one was just 0. So that ended up shorting the mains directly in below the fuse. This is a very common failure mode for these kinds of things, and a nice one. There's only current flowing from the switch and the mains part and directly there, and that's it. Nothing else is really affected. I took out the main 400 volt capacitor as well. It was still functioning, I believe. It would work, but might have seen some negative voltage there because of the rectification fault. It's old, and it's been very, very hot. It's right next to this very hot resistor and this hot transistor. The case was deformed, so yeah, this melted. So this area has been rather hot previously, so that capacitor has been cooking. It's an 85-degree job, quite an old one. So yeah, I replaced that. I happen to have a similar 400 volt 47 microfarad cap, so I just replaced that as a precaution. I replaced all 4 of these rectifier diodes because I have a bag of them. They don't cost anything. They're cheap stuff from China, so I just replaced all 4. Other than that, this 100 ohm resistor gets quite hot, but that's by design. On the board we can see there's places for 2 resistors end on end, so they tried to put 2 smaller resistors over there probably first to dissipate and spread the heat a bit around. The board is very blackened. This one is standing off the board now. It seems to have fed rather well. It's a 2-watt 100 ohm jobby. Seems to work. It's still in spec, so I didn't do anything. I did pull it out for testing, and while doing that, the blackened charred connections on the board were quite bad, and I don't know if it's because of me desoldering it or if it had happened already before, but certainly the trace on the board had lifted and broken from this end, so I made a little jump wire there to connect this resistor to where it's supposed to go with a wire instead of just relying on the burnt traces on the board. Like I think I mentioned in the last video, somebody has previously repaired this in 2015. These 2 small electrolytics seem to have been replaced, and this may have been replaced at the time as well, this resistor. I pulled all the caps. I pulled the mains cap off anyways to get access to the diodes. I pulled off the secondary side caps. I measured them. They're absolutely fine. So if you're going to go and say, oh, it's the capacitors, you have to replace the electrolytics, they always fail. Well, not really, not in this 80s technology. These are the big ones, the bulky, these are fine. ESR is very low, they're oversized for what they do. I just pulled them out, measured them, they're fine. I put them back, I didn't replace them. I measured the rectification diodes on the secondary side. And all the semiconductors I measured the switching transistor, they seem to be fine, so I didn't do anything else with them. Replaced a new fuse, of course, 1 amp fast, 1 amp, so if something bad happens again, this will hopefully fail quite fast. I don't think this small mains capacitor will cause any problems with inrush currents or something like that. The switch contacts were very blackened, so I did clean them off with just a bit of IPA and elbow grease. It's a bit loose still to fit. I might squeeze these connectors a little bit tighter together just to make sure they're on there tight. And clean the neutral and the earth connectors, the blades on the board, to get a better contact as well. After that, that was probably the main failure mode. So after that, I just plugged it in to my current limited supply. It seemed okay. I was drawing happily a couple of amps, and then just connected her straight to the mains and drew about half an amp through the 12 volt line, and I did a load test on my programmable load on the 5 volt line all the way up to 4.5 amps, which is its rated capacity. Yeah, about 5.3 volts coming out normally. I think this one works a treat. So yeah, nothing too much to do with this other than put it back together. I did replace 2 of these smaller electrolytics. They had a slightly higher ESR. Maybe it was needed, maybe not. But anyways, the small ones tend to fail more often than the big ones. So this one here on the mains, this is probably something to do with the power supply to the control chip. Perhaps, I'm not quite sure. I didn't trace the circuit. I don't have a schematic for it right now. I didn't need it for this job, so I didn't do a full schematic. And I replaced this one. It's probably the minus 12 volts stabilization, I guess. I just replaced it because I had some. They were the same type that I put here, because this one has been cooking right next to this hot resistor. So this one had a higher ESR than this one. So it's actually a different type as well. So yeah, I just replaced them both with a 470 mic 16, actually a 25 volt. So this is a 16. I put it at 25 volt. Just I have loads of these, so why not? And yeah, according to my testing, this works fine. So I'll put it back in the case. I just wanted to show the final form. I resoldered a lot of the connections here, like this switching transistor kind of flipping in the breeze. All the parts to move, the wires, the connectors, I resoldered all of them with lead-based solder. So it's just if there's any cracked solder joints from movement or heat, improved that, checked for solder balls, and cleaned up the board quite a bit. I began by initially I just put this under the faucet and just rinsed it with water and a toothbrush, and just cleaned the gunk off it. It's a lot easier to work with this, and then some IPA, and clean up the flux and burn stuff on the board, and it was nicer to work with after that. So I'm calling it goods. There is still the matter of attaching this teensy little heatsink onto the main switching transistor. I will put some heatsink compound there. It was a dry joint before. I'll put some heatsink compound there just to maybe improve the heat sinking a tiny bit. I don't think this thing gets very hot, but anywho, it's there, so I'll put some heat sink paste there and slam this back in. That will be fine. I did have a better heatsink like this. That would have been much more efficient for this one, but wouldn't quite fit into the board, and I think it would interfere with the case, and it probably doesn't really need it. I measured like 40 degrees here when I was testing anyway, so it's not particularly hot. This resistor gets to over 100 degrees, so that's why it's good to have it standing up and just dissipate the heat away from the capacitors and other things on the board. Yeah, I think she's right to go, and get to go for a few more years. Maybe something else, maybe the transistor will blow or something. The control chip seems to be fine, and the voltage reference was fine, so yeah, this is a repairable machine anyways. Everything is very simple. It's quite basic. It's all through-hole discrete components, so there's not much on this thing that would actually be unrepairable. Maybe the transformer is kind of hard to find if the windings would go bad. Not very likely to happen. The control chip might fail. If you don't find a match for that, then you might be out of luck. Everything else here is just Bob standard parts, jelly bean stuff. You can get all of the things here today, and you could just rebuild the whole board with new components, no problem. So I think, yeah, this is a nice model for the Amiga. 4.5 amps, plenty of capacity for a 500 or a 600 or even a 1200 with some expansions. Repairable. I mean, doesn't have a crowbar protection circuit, so if something were to go crazy and the voltage would go sky high, you'd be in trouble. So using these vintage things, you'd probably want to have like a protection module, maybe in here, or maybe wired over there. It's just a crowbar circuit to react, so that if this thing does go over voltage, it would just short the output, blow the fuse or whatever. Just protect your machines that are not made anymore these days. So yeah, that's something to consider. But yeah, I wouldn't hesitate too much plugging this into my Amiga every now and then. But as a daily driver, for that I would build something modern with the protection circuit, with the crowbar circuit, with just better design overall. But hey, this original works beautiful. See you in the next one.